Hello and welcome to the channel Beyond the Curve, and I'll be answering question number 2 of the FP1 May June 2024 paper. So it says function of z equals z cubed minus 13z squared plus 59z plus b. Given that z equals 3 is the root of the equation if z is equals to 0, show that p equals minus 87. So we equate the function of z to 0 minus 13z squared plus 59z plus b. We equate it to 0 while substituting 3 for z. So let's say f of 3 equals 3 cubed minus 13 into 3 squared plus 59 times 3 plus b. Let me put this into my calculator and equate it to 0. 3 cubed is 27 minus 13 times 3 squared, that is 117, plus 59 times 3, that is 177 plus b. Let me simplify it. 27 minus 117 plus 177, 87 plus b. Subtract 87 from both sides and we get b equals minus 87. Shown, because the question specifically asks us to show, so I've written it. Let's move on to part B. Use algebra to determine the other roots of the function equals to 0, giving you answers in simplest form. So since this is a cubic equation, the equation is going to have 3 roots, one of which already is given in the question, and the remaining 2 we're going to find them. So I can write the function of z is equals to z cubed minus 13 z squared plus 59 z minus 87. This can be written as z minus 3. This is because the question already says that z is equals to 3, so if we move the 3 to the other side, we get z minus 3 equals to 0. This is one of the factors of the cubic equation. So this z minus 3 is going to be multiplied by a quadratic function, a quadratic expression, which would give us the cubic equation. So I'll write that as az squared plus bz plus c. We can figure out this quadratic expression by doing a long division. Let me do that on the next page. So that's going to be z cubed minus 13z squared plus 59z minus 87 divided by z minus 3. So z cubed divided by z is z squared. Z times z squared gives z cubed minus 3 into z squared is 3z squared minus 13 minus the minus 3 is going to give us minus 10. We bring down the plus 59z. So minus 10z squared divided by z is going to give us minus 10z. We multiply z times minus 10z is minus 10z squared. Minus 3 times minus 10z is plus 30z. We subtract 59 minus 30 gives us 29z. We bring down the minus 87. We have to multiply by a plus 29 to get a 29z. And then minus 3 times 29 is minus 87. Or if we subtract and get a 0. So we can rewrite the function of z as z minus 3 times z squared minus 10z plus 29. Now we can clearly see that there are no two numbers that can add up to give a minus 10 or multiply to give a 29. So therefore we don't have any real roots. So we have to apply the quadratic formula to get the imaginary roots of this quadratic expression. So let's apply. Z equals minus b plus or minus b squared minus 4ac, square root of it, whole thing divided by 2a. So if I substitute the minus 10 into the b, the minuses cancel off and I get a plus 10. Plus or minus 10 whole thing squared is going to give us 100 minus 4 times a is 1 times c, which is 29, square root over 2 times 1. This gives us 100 minus 4 times 29, that is minus 16, divided by 2. So we can simplify this to 10 plus or minus square root of minus 16 can be written as square root of 16 times square root of minus 1 divided by 2. And we know that the square root of 16 is 4 and the square root of minus 1 is represented by I. So it's 4i divided by 2. We divide by 2 and then we get 5. Sorry, let me just erase that. Oops. Okay. 10 divided by 2, that's 5. Plus or minus 4 divided by 2 is 2. So 5 plus or minus 2i. So therefore, other roots of this equation or of this function is 5. Other roots are 5 plus or minus 2i. And that's our answer to part B. Part C. On an Argand diagram, the root z equals 3 is represented by the point P. Other roots are represented by Q and R. The number z equals minus 9 is represented by the point S. Show on a single Argand diagram for the the positions of P, Q, R, and S. Right. So let me draw the Argand diagram. Ruler. Okay. this is going to be our imaginary axis of z, and this axis is going to be the real axis of z. Okay, so let's mark our points. The first point is z equals 3, which is represented by p. So I'll mark it over here, 3, which is, well, point P. Other roots by Q and R. So the other roots are essentially 5 plus L minus 2I. So 5 can be shown here, plus 2 will be this, minus 2 will be this. So this can be point Q and this can be point R. Next point is z equals minus 9, represented by S. So this is far off to the left side of the axis or the Argand diagram. So this is minus 9 and this is represented by S. Cool. So I'll take my ruler again. Oh, I don't need my ruler, sorry. So these are the points represented on the Argand diagram, so that's the answer to part C. I'll be needing the ruler for the part D. Part D says determine the perimeter of the quadrilateral PQSR, giving your answer as a simplified third. Okay. So now I'll be needing my ruler. Okay. Oh, that doesn't seem very nice. So I'll use the same Argand diagram. Alright, there we go. Not a perfect one, but it's alright. So now we can see that the sides SQ and the other side S are of the same length, and the other sides PQ and PR, they're of equal length as well. So if we find one of SQ or SR and one of PQ or PR, we can find the perimeter of the quadrilateral. So I'll move on to finding the length of SQ. So the coordinates of Q, we can take it as 5, 2, and coordinates of S as minus 9, 0. So it's going to be 5 minus 9 whole thing squared plus 2 minus 0 whole thing squared and square root of it. So let me find the length. It says 5 minus 9, which is 14. We square it we get 196. We add that with 2 squared. 2 squared is 4, so 196 plus 4 is 200. Square root of 200 is 10 root 2. Now we also know that this is equal to the length SR. Now we'll find the length PQ. PQ, we can take the coordinates as 3, 0 and Q as 5, 2. So let's say 5 minus 3 whole thing squared plus 2 minus 0 whole thing squared. Oh, that doesn't look nice. Okay. Equals 5 minus 3 is 2, so 2 squared is 4, plus 2 minus 0 is 2. 2 squared is also 4. Again. So that's 8. Square root of 8 is 2 root 2. Which is also equals to PR. So, perimeter of PQSR is length of SQ plus length of SR plus length of PQ plus length of PR. Alright, SQ is 10 root 2 plus SR is also 10 root 2 plus PQ is 2 root 2, PR is also 2 root 2. Therefore, when we add all of this, 10 plus 10 plus 2 plus 2, it's 24 root 2. And this is our answer to part D. Sorry, I forgot to mention it. Yes, answer to part D, the perimeter of PQSR. And that's the end of question number 2. If you liked this video, please like and subscribe this channel, and I'll see you soon.